To get it started with this particular custom variation, we're going to do things a little bit differently. We've already created the custom variation, and what we're going to do is unpack it. Using the custom variation found by double-clicking or clicking on the little plus icon in the variations area found in the design data form, we can choose custom variation, and then this particular variation is called insert append dish through intersection / knuckle. What we would recommend you do is before you actually run this is click download scripts, and this will ensure that you are running the absolute latest version of this particular script, as it has undergone some improvements since its initial launch back in v25. So let's have a look at how this particular variation has been applied. What we've done is picked a start chainage and an end chainage for where this dish should occur, and it should occur through this intersection. And what we're going to do is use the Kerb Return Strings that have been applied on both sides. This is KR1 and this is KR2 to constrain the extent of the creation of this dish. The dish itself is made up of 3 new codes. Namely, we have an EB2 code, which is this one here. We have an INV2 code, which is this one here. These correspond to what you can see is going on in this cross section as well. And then lastly, we have the BK2 code. Importantly, the LEB, which are all being assigned to the Eyelet Street template here, is the last and final code. This is your through code on your intersection. So the way that we've compiled this is, first of all, we've picked chainage ranges. Now it's important that when you pick the start chainage and the end chainage, that you pick inside the Kerb TP point on both the start and the end of where your dish will go. Now don't worry about the trimming, because the software is actually going to be doing that for you, but you need to ensure that when you pick the start chainage, you are inside the Kerb TP at the start, and when you pick the end chainage, you are inside the Kerb TP at the end there. The road edge code, which is essentially your through code for your intersection, traditionally would be REB or LEB. In this case, this is LEB. Now the code that we are going to replace through here for you is going to be called EB2. You can name this whatever you want, but the reason why we're adding 2 onto all of these as a suffix is to ensure that you don't end up with a duplicate code name on the same string. What we're doing is constraining the dish with a Kerb return, which is KR1, which is here, and KR2. And there's good reason for that, because this particular script will look at the position of the alignment of your Kerb returns and determine whether or not it can draw each different code for your dish. And you'll see that in action very shortly. The actual dish shape itself is controlled by this segment. So we're putting in a code which is called INV2, which is what you can see here. And then we're simply offsetting 0.3. You don't have to put a negative value if you're going left or right. You can simply put an absolute value. Then we are going down 40 mil. Then for the other side of the dish, we're going back up to a code called BK2, which is just in here. It's overlapping by a few mil with the LEB code. That is going across 300 mil and up 40 mil. Now, I've already applied this particular variation, and this is the result. So what's happening is it's looking for the nearest available section after the Kerb TP, which is this one here, and drawing those 3 codes, and then putting the EB code, which you can just see there, putting that round the back to ensure that you still get a proper intersection. So what we also offer you is the opportunity to add extra spacings or extra sample sections of a nominated value, and this means that it will basically go from the start chainage of 270.306 and look to draw, if it can, bear in mind it's constrained by the Kerb return, the first part of your dish. So let's have a quick look. We'll click add extra sections. Now as soon as you click add update with this variation, you need to immediately click recalculate, because these extra sections are being added in the background. So it's important you click recalculate immediately. And as we do that, you'll see that because we've now got 1 meter sections, in fact, if I just now do a regen in the drawing, those 1 meter sections being added in, and you can see that the software is now constraining the drawing of those particular codes to those particular sample locations using the extent of the Kerb return on both sides. This is a really neat way of being able to add in a dish within the intersection whilst maintaining the connectivity between the 2 roads and maintaining an intersection. What we'll do is quickly just turn off the sample lines for Eyelet Street. We don't need to see those at the moment. And then we will head to tool space here, right click on total model and click add water drop. And you can see as we do this, that live jig of that water drop is demonstrating that the water is actually ending up in that dish and then being pushed through towards the north of the intersection. Now, if at any point you make any changes to, for example, your Kerb return geometry, or even if you were to reopen this project, these extra sample points that get added in via the recalculate need to basically be regenerated. So if you make any changes to a Kerb return at the intersection or road 1, or for that matter Eyelet Street, ensure that you immediately come back to Eyelet Street. And I'm going to use tool space here. Right click on Eyelet Street, which is your main road, and click resample sections. And what that'll do is that'll immediately resample your road and add in those extra sections for you where appropriate.